This particular notation is a way of referring to a function that focuses on the inputs and the outputs instead of how it's represented. For instance, whether it's a bubble diagram, or it's a table, or a formula, or a graph. In typical function notation, you'll see pieces that have something like f of x here, and that's the way we read it, as f of x, and on the other side of the equal sign is a y. The function is always given a name like f, and it doesn't have to be f, it could be g, it could be a word there, but it's something that usually helps you to understand what's going on in the application. What's next to it is a set of parentheses with the input variable inside there. So in this case, our input variable or independent variable is x. And then on the other side of the equals is the output from the function, or the dependent variable. And basically what this is telling me here right now is that f of x is the same as y. So whatever comes out of this is just an output. So in any problem, a portion of this notation may be missing, or the sides around the equal sign may be flip-flopped. It may be written as y equals f of x. Means the same thing. So let's take a look at an example. So what I have right here is a graph, and I've got some data points on here in red, but this straight line shows the relationship between a Celsius temperature and a Kelvin temperature. Those of you that are taking chemistry or something like that know that if you have a Celsius temperature given by C, if you add 273 to that, that gives you an output of Kelvin. So my independent variable here is C, representing Celsius. My dependent variable is K, representing Kelvin. And so I can think of this as a graph or as a formula, either way. If I want to put this into function notation, what I'm going to do is I'm going to take the dependent variable k and replace it with function notation down here that's appropriate. What I've decided is, because we're talking about Kelvin here, I'm going to go ahead and call this with capital K. Here are the parentheses that we talked about, and now the input variable goes inside of that. And for this particular problem, the input variable was C, so I write K of C. On the other side of that, I've gone ahead and written out what the formula is for getting the output. So we'd say K of C equals C plus 273. And so now if someone gives me a number inside here for C, I know that they want me to put it into C in the formula, and that gives me the output. For instance, if someone says K of 0, what they're trying to tell me is we're corresponding with C, a value of 0, and that gives us an output, 0 plus 273, or 273. So an input of 0 gives me an output of 273. And what you'll notice is up here on the graph, that corresponds to the point 0, 273. So I have inputs and outputs on the function notation. I have inputs and outputs on my graph. Now, what happens if I go ahead and put 100 in? So now I'm corresponding with C, a value of 100. So I need to do the same thing in the formula. So I get 100 plus 273 is 373. So an input of 100 gives me 373. And up here on the graph, you see a point at 100, 373. So there's the input, there's the output. So sometimes you might just see this written, K of 100 equals 373. They might just leave out this piece here because it's so easy to calculate. But input is inside the parentheses, output is on the other side, so it just corresponds to that ordered pair, and we can put that on a graph. And in fact, we can go to almost any place on here. If I go ahead and pick a point right here, I see that that's roughly at about 75, and the output is up here at about 350. To figure out the exact output, we could come down here and put in 75. And let's see, 75 plus 273 looks like it's about 348. So this point is at 75, 348. In addition, you'll notice that every time I'm putting in an input in place of C, I'm only getting one output. That's telling me this is a function. But if someone uses function notation, you have to assume that that's the case to begin with. Now let's go ahead and take a look at that table we were working with before. Now, remember that our input was persons and our output was the years. So I'm going to go ahead and write out function notation here. So in parentheses, I'm putting the person, and on the other side of the equal sign, I'm putting the years. Now the name that I've given to this is the word age. So age of person comes out in years. Now it's a little bit cumbersome to keep carrying around that whole word person and years. So often what you'll see is we'll go ahead and just represent person with P and years with Y. So we write age of P equals Y. So this tells us that if you input a person into the age function, you get the number of years, and the way we do that is by using this table right here. So if I write age of Ron, all I want to know is what is the age of Ron, so I go over to the table, I find the correspondence, and so I know the age of Ron is 18. And that's about as simple as it gets. Another thing that can happen is if someone says age of person equals 29, well, they want to know what is the person that has an age of 29. Well, in that case, we look at the correspondence right here, and we know that the person is Tia. So in the first case, I gave you what the input is and asked you to find the output of 18, but I could also do it the other way around. I could give you the age and ask you to come up with the person. So in this case, the person was Tia. So now let's look at one that is probably more like what you're used to seeing before. I've been trying to give you things that are a little bit unusual so you get this idea that a function is a particular kind of relationship between inputs and outputs. So now I'm going to go ahead and give you what you're used to working with. This might start out as y equals 2x minus 1, but when I want to write it as a function, I replace the y with f of x. So let's go ahead and use this function notation. So if I see f of 7, I know what that's trying to do is it's saying in place of x, place 7. So I get 2 times 7 minus 1. And 2 times 7 is 14, minus 1 gives me 13. Here's where things get a little nasty. In the previous one, I gave you a very specific number to put in there. So now if you don't see a number, you see a letter instead, what's that asking you to do? Well, it's really simple. Before we corresponded x and 7, and I put it into the formula. Now it's just saying correspond with x, the letter t. So I put t in place of x. I get 2t minus 1. And we really don't need the parentheses there, so I can just write that out. Essentially, all I'm doing is I'm saying instead of calling the input variable x, call it t. So if f of x was 2 times x minus 1, f of t is 2 times t minus 1. All I'm doing is just changing the letter. Now let's make it a little bit more complicated. So now if I ask for f of x plus h, what I want you to do is I want you to correspond with x this entire group of symbols here. So in place of x, So where I saw x up here, now we're putting x plus h. And so what I end up getting is 2 times the quantity x plus h minus 1. If I go ahead and distribute my 2 onto each one of those pieces, I get 2x plus 2h minus 1. There's no more simplifying I can do there, so I'm just going to leave that the way it is. What about f of 1 over z? Just like the previous one, I had a group of symbols here, and I put that in place of x. Now I'm going to put 1 over z in place of x up here. So when I do that, I get 2 times 1 over z minus 1. And if I simplify that a little bit, it gives me 2 over z minus 1. What should you be taking away from all of this? Well, all x is a place to put something, the input. So 2 times x minus 1, if I put 7 in there, I get 2 times 7 minus 1. If I put t in, I get 2 times t minus 1. If I put this group of symbols in, I get 2 times the group of symbols minus 1. Here's a different group of symbols, but it still works the same way. I'm putting things in place of the input, and it gives me a new formula or maybe a new output. Now let's do something a little bit different. Before I was placing things in x and figuring out what the output is. Now if someone says for what value of x is f of x equal to 11, I haven't supplied you with an input, but I did supply you with an output. So how are you going to tackle that? Well, it's pretty straightforward. All I'm going to do is take my formula up here and set it equal to 11 because the formula is how I get the output, and I say I want the output to come out to be 11. So I want 2x minus 1 equal to 11. So I just set the function equal to 11. So now I need to solve for x. So if I add 1 to both sides, I get 2x equals 12. If I go ahead and divide both sides by 2, that gives me x equals 6. So what that's telling me is when I do an input of 6, I get an output of 11. F of 6 is 2 times 6 minus 1, and it indeed does give me 11. If I give you an input here, you put it into the formula and get an output. Here I was giving you an output, so you set the formula equal to that output and then solve for the x, and then you can verify it at the end, like I did right here.